Hi guys, how are you? My name is Carlos Rodriguez Iturria, and in this session, I'm going to be sharing with you a story that goes around preventing data breaches despite vulnerabilities. I am the CTO of Synapsewerx. We are a data boutique. We care about all aspects of data, from integration, security, and these days, what keeps us out of the bed in the morning is building and orchestrating AI agents. In this session, our mission is to share with you a story of something that happened earlier this year when we wanted to try an experiment. We wanted to try a different type of hackathon. It was not the typical red-blue team hackathon where we bring the red team, the ethical hackers to try to hack an applications, and the blue hackers, the blue team trying to stop that attack. It was a little bit different. What we wanted to do this time is something that we believe is important. Had a twist, and I'm going to share that in a minute. But basically, there was something that we wanted to prove. I'm going to share with you what happened, what we learned, what were one of the biggest struggles, but also what were one of the biggest lessons. And then I'm going to show you what is next. That's our main mission for the next 20 minutes. But we also have a small mission. And when I presented this during the API days in a physical room, it was easier. But now that you are watching this video, I just want you to see. I'm going to be presenting with you a couple of images, photographs, right? And your mission is to watch them very, very carefully, and then you have to decide whether you think that image that I'm showing you is real, or whether that image is made by AI. Like, for example, in this case, do you think this image of an astronaut taken on Mars is real, or is fake, or it's taken made with AI? Well, obviously, this is easy, right? Because, well, obvious reasons. The prompt that we used for this was an astronaut girl wearing a high-tech life support suit on planet Mars, surrounded by futuristic colony buildings. I promise this is going to get a little bit more tricky, so you have to pay attention, okay? Okay, well, let's get started. What was our motivation around doing this different type of hackathon? Well, first of all, let me just explain to you what it was all about. We wanted to bring organizations to basically like experts around cybersecurity, and we wanted to give them a challenge. The challenge was going to be an application that was designed with multiple flaws, different levels of flaws, and security vulnerabilities. And their mission was to find them, find this vulnerability, exploit these vulnerabilities, because we were going to basically give an award to the team that is able to find the most vulnerabilities and destroy the application. Each team was going to have their own independent application. But that was not the real end of the exercise. We split this in 4 tranches, as I'm going to show you in a minute. But ultimately, what we wanted to do is, after each of these stages or tranches, we wanted to basically make a pause and basically just show them, like, say like, okay, these were all the list of vulnerabilities that existed in this application. These are the ones that you guys found. You missed this, and that. Everybody found this. Only this team found this one. And then after that, we're going to do a small tweak. We're going to protect the same application with the same flaws. And then once everybody know about all the vulnerabilities, we're going to ask them to do it again. But this time, it was going to be protected with a surrounding security platform. And the whole experiment, well, what we were hoping to achieve, is that after each of these attacks, they were going to try it again. The same thing that worked before, even more now, because now they know about all the vulnerabilities, and even we showed them how to hack it. Basically, the whole idea is that the whole framework around it was going to identify these vulnerabilities in near real time, and it was going to stop them. And with this, the motivation was not to promote a bad engineering. On the contrary, what we wanted to do is to make a point. And the point is that it doesn't really matter what you do. You can design for the best possible security in the world. At some point, because we are humans, there's going to be a human error. And that human error is going to eventually show with a vulnerability, and there is really nothing we can do to prevent that. What we can do is to ensure that we have a framework in place so that when that happens, then we are going to avoid data breaches. So that's what we wanted to prove. And then it takes us to this picture. So can you watch carefully this picture of this photograph of the rock and then think whether you think it is real photo or whether you think it was generated by AI? I'm going to give you a couple of seconds. Well, believe it or not, this one is real. And I'm messing with you because this was taken from the Wax Museum in France. And so obviously it is a real photograph, but it is not the real person. It was a wax statue. Okay, look, I constantly share this type of news. And, I shared this last year, and I've been talking about this for the last couple of years. When we start reading this type of data breaches every day, or at least very often, we sort of have a mixed feelings, because we have multiple hats. For example, in my case, when I put on my end user hat, well, I get very concerned. I get worried because I know that eventually sometimes I get emails or I get an SMS where the hacker, I know it is not a legitimate SMS or email. They're calling me by name. Obviously, they have my mobile and email. So I'm thinking, what else do they have? How much of that exists in the dark web? So that gets me very, very nervous. What about my family members? They may actually have information about them too. Then I put on the other hat as a technologist. And as a technologist, I get very excited because this is a problem that is getting more difficult to solve every time. But, it is exciting to have the opportunity to solve this problem. And that is why all the motivation behind doing an exercise like this one. So let me tell you what happened during the day. So we invited a couple of financial institutions, big financial institutions that are well known for having a lot of experience in the realm of cybersecurity. And we basically split them in red teams, and each one of them received their own containerized application made up out of multiple microservices. Each microservice, as I said, was going to categorize with different levels of vulnerabilities that we designed explicitly. And their goal was to bring the best toys, bring the best toolkit in order to identify and exploit as many vulnerabilities as possible. The team who found the most and exploited the most vulnerabilities won the award. Okay, and after each tranche, basically we stopped them and said, okay, look, guys, this first tranche, we wanted you to identify 20 vulnerabilities, and everybody found this and that. Not everybody found this. Okay, now try it again. And we were very, very excited to see that after we use the technology to surround the security, and there are a couple of technologies that can do that, but we use one in particular that is probably the best of the world in order to secure the application. Well, it was able, the application, the whole security framework was able to identify in real time these attacks, and they were able to stop them. So whatever worked before, the cybersecurity experts were very excited to see that they could not continue exploiting those vulnerabilities because the security framework stopped them. So they were very happy. Obviously, they were thinking like, okay, well, this is it. It is all about having the right framework in place. So let's talk about that. But before that, let me show you this picture. Have a look at this picture very, very carefully and tell me, do you think this is a real picture or was this generated by AI? Well, this was generated by AI, and this is how good AI is getting at generating very, very realistic photographs. The prompt that we used was a realistic photo of a cybersecurity hackathon. Pretty cool, huh? Okay, so these were the 4 tranches that we used. The first one, as I said, very, very basic. with pretty much any of the scanning tools that they brought. They were scanning the network. They were able to identify a lot of unprotected endpoints. They were able to identify endpoints that have very, very basic authentication, and they were able to hack quite easily. With simple penetration tools and dust, they were able to identify a lot of vulnerabilities, a lot of ways to do parameter tampering and SQL injections. Then, moving to stage 2, it was still basic, a little bit more sophisticated, but still, most of the tooling that they brought were going to be showing a lot of basic OWASP vulnerabilities. And then, using Burp or Zap proxies in between the browsers and the APIs, they were able to intercept a lot of the traffic, open it up, and see like, okay, guys, you are sharing a lot of data that I can use in order to do session hijacking or simple token manipulation, or just a simple denial of service, distributed denial of service, and literally be able to burn many of these microservices. So we can say that, out of all the vulnerabilities that were designed and were planned as part of these couple of first 2 tranches, probably around 80% of them were identified and were exploited by the team. So we were very excited, and even more excited to see them that trying that again after the security framework in place, they were not able to continue hacking. But then we moved to stage number 3, the tranche 3, which was a little bit more advanced. We were still playing with BOLA and BFLA from the OWASP, but these levels of authorizations we try a bit more complex things. And the broken object level authorization, it's top one in the 10 OWASP vulnerabilities for a reason. A simple object can be the user ID, but there can be multiple objects that are actually very, very hard to identify. And also there are a lot of, with broken function level authorization, there are a few functions that are actually quite hard to identify. It is not as simple, the simple, I changed the get for a delete and I tried again, and yes, I was able to delete something. Well, it was more in the tranche 2. With this, we tried a bit more complex things, and many of them, we can say that probably only around 5% of these vulnerabilities were identified and were exploited. And this is for a reason. We humans are not very good at, unless we have the right tooling in place, we are not that good to make a lot of associations by looking at a lot of data and trying to identify the patterns. We are really not that good at that. And we basically proved that with tranche number 4, which by design, it was meant to be very, very hard. It was meant to simulate what a real world attack is all about. It was all about trying to exploit business logic. And doing an account takeover that is not as simple as a session hijacking. It was something that it can be considered more elaborate, but it's really not, doesn't have to be. It is just difficult to be identified and be exploited. Even though those vulnerabilities were there, well, they were not being able to be found. And even we told them, the guys, there are these vulnerabilities, go and find them. They were not able to identify them. And let me try to explain why that is the case. Let's take the example of an account takeover in a real life scenario. Imagine a user that has an account that, imagine that person is allowed to approve payments for up to $50,000 per month. Okay, $50,000 per month. And imagine that whether through very sophisticated mechanisms or simple social engineering, stealing a Post-it from a wall, someone is able to impersonate this account with an account takeover. And let's say that this person goes and tries to approve a payment for $20,000. It is way within the limit. So how can we identify that this was generated by a fake individual, or how can we know this is an exploit situation? It is pretty hard, right? Without giving you much context, it is going to be almost impossible to know that it is not a legitimate transaction. But if I start giving you more context, for example, the real person makes these approvals every end of the quarter or every end of the month, and normally they do it on Mondays from 10 to 12 p.m. And this hack or the vulnerability, the hacking was executed on a Friday at 5 p.m. So very quickly you can start seeing like, oh, that sounds dodgy. I reckon that this was an attack. But this is the thing, right? Like imagine that now we have to have this level of ability to identify based on context and being context aware across pretty much every single API invocation across a large group of applications. Like it is impossible, right? And then to be able to do that in near real time is it's almost impossible. So what basically we wanted to prove with this is that unless you have the right tooling in place, tooling that ultimately is going to have a smartness with artificial intelligence, it is not going to give you that ability to identify and stop these situations in real time. So, with being context aware, it basically means that you have to pretty much store all of this information and learn over time, identify these seasonal patterns. And when they apply, basically be able to say, look, this is an anomaly detection. I'm going to throw this as a exception, and this is a hacking attack. And maybe not. Maybe simply that person happens to be doing a particular new thing that happens only every end of financial year. And that's fine, We can say like, okay, no, learn, because now there is going to be another seasonal pattern that happens just every 12 months. And that's fine. But, at least we are going to be able to give this ability. So, what were the lessons learned? Before I show you the next picture, out of these two photographs, can you tell me, look at them very, very closely, and tell me which one do you think was generated by AI and which one do you think is a real photograph, a real person? Well, believe it or not, both are generated by AI, and you can even see some wrinkles on the forehead of the person on the right. You can see some pimples and some skin marks, very human on the picture on the left. But again, this is how good AI is getting. So anyway, what did we learn and what did we prove? We basically proved what we wanted to prove, which is unless you have the right tooling, you are not going to be able to identify and stop data breaches that happen with more sophisticated attacks. Simple stuff, absolutely. Bring your own tools, bring your team, and you are going to be able to do it. But remember that attacks are getting more and more sophisticated. And we also proved that for context-aware type of attacks, then literally you cannot do it. A human cannot do it on its own. A team of experts cannot do it on their own. They need proper tooling that is now evolving into pretty much behind the scenes building an internal data lake or a lake house that is ultimately storing all of this information, learning from this information so that they can identify patterns. And this is really what we have to start using these days. But then at this point, we were happy. We were like, okay, well, this is the end of the exercise. So we only need to bring this technology and that's it. We are all happy. Well, we felt happy at that moment. But guess what? A storm is coming and things are getting more and more complicated. Don't worry about this image. This is definitely AI. And the prompt that we used was, how does AI visualize an AI agent? Pretty interesting, right? Well, the storm that is coming is that AI agents are taking the world by surprise. These quotes from these guys, it was taken literally a couple of weeks ago during, Eric Schmidt, ex-Google CEO, was talking at Stanford. And basically, he was talking about the AI agent revolution. And Larry Ellison, a couple of weeks ago during Open World, he was talking about, there is a race. And there is a race that only a few countries and only a few companies can win, because there are basically billions and billions of dollars that need to be invested. Mark Benioff during Dreamforce 2024, he was on a stage saying 1 billion new AI agents within Salesforce in the next 12 months. And I believe him. And if you think about it just for a minute, if APIs are the ears, the eyes, and the hands of the AI agents, well, how many new APIs are going to be created with 1 billion AI agents? We are talking about billions and billions of APIs. And just when we thought that the API sprawl problem was getting out of control, this is just going to get even worse. And the reason why the security aspect of an AI agent is even more difficult than an API is because, well, at least an API is deterministic. If you don't change the backend application and you send the same input multiple times, well, most chances you are going to get the same answer, right? It is not going to determine and come up with something that is going to return a completely different answer. But AI agents tend to basically have multiple levels of data. Most AI agents use one or multiple machine learning models that were trained with data. So just the neural network that is embedded within the model already contains data. What data? Who knows? There was another experience from Google. They were building from scratch a model, and they were just basically given it data, and suddenly they put it to test. And one of the engineers started talking to Hindi to this model, and the model started understanding and replying in English, and they were completely, baffled because they never trained that model to learn or know anything than English. So where did it learn another language? It's probably it must have been inherited from another foundational model, but these type of things are very, very hard to know. And we as technologists trying to secure an AI agent, not even knowing what data was embedded in the model itself, then that's difficult. And then if you think about all the data that is surrounding the AI agent, it's going to be even more difficult. And this is why, just to finish, this is what is next. We want to do this again. We want to do this exercise again, but this time we want to bring the same, probably the same traditional application made out of microservices, containerized in Kubernetes, very traditional APIs, but also we want to bring AI agents because we want to show people how is that, what are the best ways in which you have to design and architect your AI agents so that you can protect them. Because the last thing that we want is to start getting a hacking attacks from AI agents, and AI agents talking to other individuals and giving information that they are not authorized. And if you remember our top two problems that we had in tranche 3, which was broken object level authorization and broken function level authorization, well, guess what? AI agents are very good at understanding large quantities of data and understanding those patterns. So they will be able to exploit these vulnerabilities so easily. This is my LinkedIn. That's a QR code for my LinkedIn. So if you want to connect with me, if you want to be part of this experience in the next weeks or months, then reach out to me and let me know. If you want to know what are the best ways in which you need to design and architect and secure your AI agents, again, these are the things that truly fascinate me and get me out of the bed in the morning. And just to finish, this last image, do you think it is real or do you think it was AI generated? Again, it was AI generated, and this looks so realistic. So the prompt was photorealistic of a micro baby green dragon on a human finger. This is how good things are getting with AI. And I hope that you found this video useful, and I hope to see you the next time. Thank you. Bye-bye.